Good morning, ladies and gentlemen. All protocols are duly observed. I'm by name Yakubu Magaji Yuguda. I'm here to present a paper titled Recent Developments in Forensic Analysis of Narcotics. So I will be a little bit fast because I'm very sorry for that. I have another case report to attend, please. So I will just, even though the slides are not much, so I'll just be a little bit fast, please. So the evaluation of sufficiency of active compounds, either as drug substance or in combination with excipients. So just like the normal drugs we used to take, tramadols, other hard drugs that they're normal medication, but our people tends to turn it into like hard drugs by abusing it. So normal paracetamol. So the active ingredients that is contained in that particular drug is called the active compounds. While other preservatives, other starches, other coloring agents, they are the excipients. So it's a critical function of pharmaceuticals analysis in production of safe and effective pharmaceuticals. So these recent advances in forensic sciences have led to development of innovative analytical methods, which are the new techniques that I'm going to discuss, that are capable of detecting, identifying, quantifying, and quantifying. So these are the keywords that we are going to put into consideration: detecting, identifying, and quantifying a wide range of narcotics and their metabolites, even in complex matrices. So as far as drugs is concerned, in pharmacology, there are two things. We have pharmacodynamics and pharmacokinetics. So now, if you consume drugs, definitely that particular drug is going to be metabolized in your system, which may undergo there's something we call fast metabolism in the liver. So that particular compound, that particular drug is going to be degraded into different compounds, into different substances, in which the active substances in that particular drug is going to be absorbed in the system and targeted a particular region where that particular drug, ailment or disease condition is in that particular. Analysis of narcotics has always been a critical area within criminal investigation, particularly in the context of drug enforcement. So now, here are some key advances in forensic analysis of narcotics. So the first techniques, we have high resolution mass spectrophotometry. So this high resolution mass spectrophotometry is a techniques that measures mass to charge ratio of the compound. So that is the working principle of high resolution mass spectrophotometry. It measures mass to charge ratio of the compound. That is, it uses to analyze unknown compounds in a sample. For example, you get a particular drug or you get a particular liquid. So you want to test, you want to know the compounds that are present in that particular drug. So if you expose that particular drug to high resolution mass spectrophotometry, so it will analyze that particular drug based on mass to charge ratio of the compounds, of the unknown compounds, that is the unknown compounds that are present in that particular sample. So this techniques, it ionizes the compounds that are present in that particular drug. After it's analyzed, so ionizes that particular compound, it creates an ions. So that ions are being separated based on their mass to charge ratio. You know, if a compound is ionized, so it splits into ions. So different ions possesses different weight. That is the mass of that particular ion, and the charge that is present in that particular ion helps that particular ions to migrate. So high weight or high molecular weight ions tends to move slower than the lighter ions. So in that process, which leads to the separation of that particular ion. So therefore, they are being separated based on their mass to charge ratio. Then at the end of that particular analyzer, there is a detector which detects each and every ion that is being ionized. It's at a particular time if it's arrived that particular detector. So it's detect that particular compound that are separated separately, individually, just as you can see in this particular uh, slide. So there are different compounds here. These are compounds that are present in that particular drugs. So they tend to move in a different wavelength based on their mass to charge ratio. So this is high resolution mass spectrophotometry. Spectrometry. Then we have ambient ionization techniques. So these ambient ionization techniques, as you can see, even the ambient ionization, the high HRMS and the ambient ionization techniques utilizes the position or the ions that are being generated in that particular compound. So it generates ions from sample within within limited or no sample preparation. So these techniques, maybe you are in a field or you get a particular drug, it's evidence in a crime scene. That is, and you have this particular ambient ionization device. So if you have that particular device, you can analyze that particular evidence that you obtain, be it drug or any other substances that you obtain. You can analyze that particular substance in that spot of the crime scene. So because it requires little or even no sample preparation. So it analyzes this particular sample compounds under atmospheric pressure. So it doesn't require any sample preparation techniques or any maybe process that you can even take it to the laboratory, process the sample or do something. You can use it at a particular crime scene for your drug analysis. Then in this ambient ionization techniques, we have two techniques, which is direct analysis in real time, DART, and also disruption electrospray ionization, that is DESI. These techniques that are being utilized as ambient ionization techniques have revolutionized the field of narcotic analysis. So because they allow rapid and direct detection of sample without need for even that is what I told you, without even need for any extensive sample preparation. And it helps forensic investigators to analyze sample in a crime scene in order to avoid any sample contamination or any other uh, biases that may arise in not maintaining chain of custody. So in these techniques, you can analyze powder drugs, you can even analyze liquid drugs or any biological samples that is being obtained. So can you hear me, please? Let me confirm.
Yes, we're
Hello.
enjoying
Yes,
it.
yes.
So,
We're
so
enjoying everything.
a lot of bias have been uh, excluded in this ambient ionization techniques. So the next thing is portable analytical device. So as you can see from this image, this portable analytical device is just something like you are just a normal POS machine or normal card reader machine. So it's very simple and it's very portable, as from the name is portable. So this device has greatly enhanced capability of forensic scientists in this field. Greatly. I don't know whether we have this kind of device in Nigeria, but in Cairo, in India, they make utilize of this all these devices. So and also in I have seen it in Ethiopia. So they also have these devices, more especially the immigration services, the narcotics, the police. Here we have the NDLEA. So I don't know whether the NDLEA and our immigration and customs of officers have this kind of portable analytical device. So this device uh, is like very simple to handle. Just like what I told you, like your card reader or normal POS. So it uses the principle of Raman spectroscopy. I don't know whether you are conversant with Raman spectroscopy and ion mobility spectroscopy, because it's like it bombards substances, it generates ion. So that ions that is being generated, it's being trapped by a laser or detector in that particular portable analytical devices, then this it will be signaled and maybe produce the result in form of pics, just like this high resolution mass spectroscopy. So you just see the result of the different compounds that are present in that particular sample as peaks. So since each and every compound or each and every atom in a particular substance absorbs light at a different quantum, at different amount, so it's quantized. So therefore, it makes it easier for these portable analytical devices to bombard other substances that is present in a particular sample and use that particular ions or ions or emission or some radiation that is being generated as a result of the excitement and detect it and record it and give us our result of that particular compound that is present in these substances. So, and also it requires no sample preparation because so it's based on molecular vibration, just by molecular vibration, that is the excitement, offering a non-destructive method of analysis that requires no sample preparation. So in this place, you can analyze your sample, you can detect your drugs or be it narcotic substances or innovative substances that are being enclosed in a matrices because nowadays the drug dealers or other criminals find a way that they can enclose or encapsulate hard drugs or any exhibit in a particular matrices. So this particular drug can penetrate or can detect substances in a particular sample without any destructive from the matrices that is being enclosed in that particular sample. So this device has become increasingly sophisticated. It's very sophisticated with a high amount of detection, be it liquid, also powder, or some anything like that. So the next thing is microfluidic and labs on a chip technology. So this lab on a chips technology, they are all advanced. Another significant advancement in forensic analysis of narcotics. This device is integrated various laboratory processes into a single chips. So be it maybe after you collect your sample, you may process with sample by you may go ahead for with sample preparation using some buffers or digestion or something like that. So, but in this particular chips, everything is being incorporated in that particular chips. So, which the
But you know,
microfluidic and lab on a chips technology uses small volume of sample, just like normal Maham RDT strip we use in detection of malaria. It's just like that one, but this one is like sophisticated. It contains chips. So if you go to the field, a crime scene, and you obtain a sample that is very small in volume, so you can easily use that particular lab on a chip technology to analyze that particular sample at that spot. So as you can see, all this advanced technology, it helps us to move away from biases that may arise from human errors or transportation or even sample preparation. These are the major challenges that we are facing now because in the process of transportation, as far as you miss the container or the 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 sample container that you are going to put your evidence or sample that is being obtained in a crime scene, so definitely it will affect your results. And I don't think you can estimate the damages that may cause. Or even during transportation, there are other environmental factors or external factors that affect sample. So then are also in sample preparation procedure. So a lot of things, just like, sorry to say, here in Nigeria, we have our laboratory practices are somehow relatively poor because we handle samples, even in diagnostic laboratory, we handle samples very carelessly and during the preparation, sample preparation techniques. There is a case, sorry to say that. There is a case, let me just debate. There's a case of a cancer patient. She was misdiagnosed with a cancer, and which leads to maybe I think it leads to her receiving chemotherapy and subsequently leads to her death as a result of misdiagnosis and missample preparation during the grossing techniques in histopathology lab. So all these advanced techniques helps us to go away from all this bias or all these mistakes that we come across. So, and it is very quick. This lab on a chip is a very quick and reliable techniques that can be done with little small sample and no even sample preparation. Then the next thing is artificial intelligence and machine learning. So this is very simple. Uh, Let me just say it briefly because in these techniques, I don't know the major challenge we have is the compound or chemical database. More especially here, I don't know in Nigeria whether we have this particular database, but in other like USA, they are preparing database for all these chemical, even India, chemical database. As far as chemicals or even novel psychoactive substances is being obtained, so it will be stored in that particular database for subsequent use. If you detect a particular compound using any of these previously mentioned techniques, you can use an artificial intelligence and machine learning tools to blast or to make comparative analysis to get more information about compounds or the results you obtain by applying other techniques. Then if you blast it, you can easily get more information. It's just like maybe using fingerprint. If you obtain a fingerprint from a particular crime scene, you lift it, you snap, take a photography. They have database as far as you blast that particular fingerprint in that particular database. So it will give information of the individual, complete information of the individual that possesses that particular specific fingerprint. So this is another advantage of artificial intelligence in machine learning. So we have forensic toxicology and pharmacokinetics. So on that, understanding this pharmacokinetics, what the body does to the drugs from absorption, distribution, metabolism, and excretion. So as far as drug is being concerned, if you take drugs, there must be absorption in that particular absorption process. So these substances or active compounds that is present in a crime scene, it's very crucial or very good to obtain samples like hair from hair sample because a trace amount of even trace amount of innovative psychoactive active substances can be detected in a hair sample, body fluid, or any other thing. So that is the essence of forensic toxicology and pharmacokinetics. So here are some challenges and future direction in this particular forensic analysis of narcotics. So there is need for standardization across laboratories, and also legal and regulatory landscape surrounding narcotics should be framed. Then future direction, future researches in this field like to focus further on enhancing sensitivity, speed, and portability of analytical methods. So need to be put into consideration, and also growing interest in development of universal database. That is what I'm trying to say, or reference standard. So database, the presence of database is very challenging, more especially chemical database. But in biology, in genetics, we have sufficient or even relatively good amount of DNA databases that are present. So here is the conclusion. Forensic analysis of narcotics has seen significant advancement in recent years, driven by needs to address challenges posed by evolving drug landscape. Techniques such as HRMS, ambient annihilation, portable analytical devices, microfluidics, and AI have contributed to improve the accuracy, speed, and reliability of narcotic analysis. As technology continues to evolve, forensic scientists will be better equipped to combat the ever-changing world narcotics, aiding law enforcement in fight against drug-related crimes. So there are other techniques that are being sophisticated also. Gas chromatography, GCMS, MS, gas chromatography, mass spectrophotometry, and coupled with mass spectrophotometer, and also LCMS, Orbitrap, and ICPOES. So they are all advanced techniques that can be used to analyze drugs or narcotics. So thank you for listening. Hello.
Hello, sir.
Hello. Can you hear me?
Yes, we can hear you. Thank you so
Oh,
much. We're giving you a round of applause. Let's give him a round of applause again.